Lecture E12, insulation materials. Let's start. Introduction, insulation materials, production, how to make them, and considerations. What do we do? How do we use it? And what are the, aspects? Badly insulated buildings lose the energy. To solve this, is necessary to do a thermal insulation at the facade, at the roof, at the basement, to reduce the energy consumption. That's what we all know and aware of. We have different materials: fiberglass, mineral, cellulose, polyurethane foam, polystyrol foam, EPS. They have different prices. They have different R values. The R values are obviously important. The flammability is also an aspect. You see all the oil-based are flammable, and the mineral-based are obviously non-flammable. And yes, they have different aspects to take care of. Some of them do absorb water, some of them don't absorb water. Others are maybe good for sound insulation as well. So that's to be taken in consideration when you make this decision. Fiberglass, mineral, cellulose, polyurethane, and polystyrene, and how to make them. Fiberglass. The molded glass is brought into a rotary spindle. Small holes allow glass dust to evaporate. These glass dust converts into fibers, and that's then the glass fiber which is used as we know it. This is a glass fiber, a sample insulation of a glass fiber. The glass fiber as a sample. Mineral wool. Close to rock wool. We're going to see both of them. The first is glass wool, close to rock wool. Glass wool refers to the sand, which is melted, which we see it there. Then it's fibers, like we saw it in the previous slide, and then brought in position. And then you see the curing oven where it's compacted. And then there's this part where the glass wool is cut into the dimensions which we need, versus rock wool, which again is melted, then crunched and fibered, again brought in the curing oven, and also cutted in the components like we need to transport. Like we need them for transport and installation. There are some thoughts about using creating slack wool as a leftover from the steel manufacturing process. Not yet that intensive in the market. Then cellulose, there we have the paper, the cardboard. It's supposed to be recycled. It's shredded, then with magnets, staplers and things like this are removed. The whole thing is crunched. There's some acid added to prevent bio impact. And then the whole thing is compacted to be used in construction. Either comes as pieces, which you can then install, or it comes as in a bag and then needs to be brought in position with, for example, air pressure as setting. Polyurethane foam. The foam is sprayed. That's a rather, uncommon use. We're going to see the other use in a second. The foam is sprayed in a position, expands to its dimension, and then is cut and then brought in position. You remember acoustics, that's something where polyurethane foam is actually quite useful. Here we see the polyurethane foam as we are more used to it, sprayed at site. So polyurethane out of a spray device, allowing to use or to be used in surfaces where it's rather complex to add insulation material with backs and forths and back cuts and things like this. And that's where it is sprayed in position, sprayed to a certain dimension, and then it depends on the person spraying it that it really comes to the dimension as the insulation is expected to happen. Versus expanded polystyrene, EPS, which comes as an agent, is boiled to expand to a certain dimension, cooled down a bit, brought into the mold. That's what we see here. Quite complex mold, which could be easily then, by reheating the agent, be filled by the polystyrene, the expanded polystyrene. The nice thing, which always is argued, yes, it's oil-based material, but it's only 2% of the polystyrene, while the rest is air, which is then covered in the bubbles. Design consideration. As we always use insulation either as an interior insulation, which we see on the left side, or an exterior insulation where the inner part is here and the exterior part is there, or a split insulation where they say the break is somewhere in the middle of this structure. And when you think about insulation, it's roof or wall. So typical roof insulation, mineral wool being placed on top of a roof with all the layers below and then some layers on top. And you also see quite nicely that penetrating these layers is not a simple one, and a thermal bridge, which we will see in a second. Another solution, not for the mineral-based, but for the oil-based, polystyrol EPS insulation at a roof. We see the watertight sealant at the bottom part, then we see the insulation. Some granulate and plates to walk on the top level, and then we go to facades. The mineral wool layer of a ventilated facade, so facade cavity, outer layer, and then the insulation with mineral wool versus the polystyrene XPS solution, where you have the inner concrete layer, then the XPS, and then a plaster being brought directly on the XPS to create, for example, a plastered surface, an insulated plastered surface as a final setting. Polyurethane foam brought in here. This is a typical sandwich setup. So we have two layers of sheet metal. The polyurethane is brought into this one, expands, laminates these two layers of metal together, and by that create the sandwich as a setting. And we see it's also capable to deal with complex geometries, as it is shown here. And now another final consideration: any penetration of the insulation obviously is allowing heat to be transported from inside to the outside, which means we need to reduce the numbers of penetration, which means that we need to make sure that the outer structure is capable to deal with the loads by the outer layer, and then transports at specific points this through the insulation to the inside. And by this, I stop this lecture. Again, typical Delft Darmstadt Munich facade education project. And thanks.